Yeah, so let's just start with today's session. Today is the fifth week of this course, and you must have seen the videos that have been released way earlier. So it concerns the different types of structures uh, that are possible, like cubic structure, octahedral structure. Last time we learned about the voids that are present. This time around, uh, okay, can Simran just mute yourself if you have any question? Okay, okay, it's fine. It's not an issue. So today let's start with the fifth week. Uh, hmm. so so the first question uh, that is given is that the example or examples of rock salt structure. So this is your NaCl structure. So basically what it presents is that, so NaCl structure, rock salt structure is your NaCl structure. So so this is your rock salt structure. If someone wants to join. Okay, right. So so rock salt structure is basically your NaCl structure, right? So what you have is just draw a simple cube, right? So this is your structure. So the atoms will be sitting at the, you know, this, this, right? This, this. Uh, yeah. So this, 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 this. Faces also. So faces also. These are the faces. And the your sodium ions, these are the chlorine anions. So this is for chlorine, right? And this is Cl minus. Your sodium cations will sit at the octahedral points. So like the edges, center of the edges, of course, right? So these are your sodium cations, right? And also at the center. So this is also the center point is also the uh, octahedral void. So so right. So this is your basic NaCl structure, and the compounds that share this sort of structure are your MgO, your MgO and CO, right? So these compounds share the initial NaCl structure, right? So what's what you mean? Okay. So the first question is uh, as you can understand, the sodium, the cations sit at the octahedral voids, right? So the you see the nearest neighboring atoms. There are six nearest neighboring atoms. Like if we consider fluorine, so there are six nearest neighbor atoms. So for sodium, there are six nearest neighbor chlorine atoms, right? So that's why they are octahedrally coordinated. There are six neighboring atoms, ions or cations or whatever they are. And same goes with chlorine. So chlorine, this here, this will be this, and on top and bottom. So there will be six. So they're octahedrally coordinated. So coming to the second question, So which of the following is or are not a Pauling's rule in the formation of solid structures? So the anions and cations must touch each other, which is the rule. So the anions and cations must touch each other. Each cation and anion should have maximum number of neighbors. This is also a rule, right? Pauling's rule, and the listed under the Pauling's rule. Total charge on cations must be equal to the charge of anions. So this is your charge neutrality condition. So this is also not true that it's not under the Pauling's rule. Neutrality, charge neutrality condition, right? The last one option is left. So phase sharing of polyhedral is preferred over corner sharing. So this is not true actually. So which of the following among them are not true? So the last option, phase sharing of polyhedral is preferred over corner sharing. This is not true, right? Yeah. So the questions. Let me just get this recording. Yes. Yeah. So if radius of a cation, the third question, if radius of a cation m is 0.54 angstrom and that of an anion x is 0.92 angstrom, then in a solid made by m and x, the coordination of cation is likely to be. So there's a rule that you must have seen in the video that ratio of radius depending on the radius ratio of the two radii of the cation and the anion. So there's a predicted coordination number. So this is radius ratio that is called. So this is called radius ratio. This is radius ratio. R. This is R of cation and R of, right? So just simply do the 0.54, 0.9. Let's check 0.92. So it comes out to be 0.58 sort of 0.59 sort of. So you must have seen that listed with this radius ratio, depending on this radius ratio, there's a predicted coordination number, and this 0.59 falls in the range of 0.414 to 0.382. So basically for those sort of radius ratio, the predicted coordination number is octahedrally coordinated, like the NaCl or the MgO structure, right? So basically what you have is that for the 0.59 radius ratio value, you have the octahedral coordination number. So this predicts octahedral coordination, right? So the correct answer would be coordination. So six neighboring atoms. So 6 neighboring atoms or ions. Okay. So which of the following, the next question, which of the following is or are true for NaCl structure? So 4 options are given. Cations occupy half tetrahedral and half octahedral. Right. So yeah. So cations and cations occupy half tetrahedral and half octahedral sites. All the cations occupy octahedral sites, and anions occupy only the tetrahedral sites. And the last option is cations and anions are both octahedrally coordinated, right? So for NaCl structure, so for NaCl, NaCl the radius ratio is R is 0.54, right? So this predicts octahedral coordination, right? So the anions, CMIs, so they will have the same occupancy because valency for valency this is 1:1, right? Stoichiometry also has to, right? This is better, right? So if a differential type of compound, so the cations, which is Na plus here, will occupy the octahedral sites, right? As true in this picture, like the green ones, they occupy the octahedral sites. And depending on the ratio of valency, the chlorine anion will also occupy your what it is called cations and anions are both octahedrally coordinated. Means the depending on the valency ratio, which is 1:1, both are same. So the just like the sodium cation, the anion, which is Cl minus, will also be octahedrally coordinated. And remind you that this is not always the case, as you will see in zinc sulfide and CF2 sort of compounds. They are not of the same coordination number. So coordination number Cn of Na equals Cn of Cl equals 6, right? So octahedrally coordinated. So the correct options would be your cations, all the cations occupy octahedral sites, which I've already shown these green ones, octahedral sites, and cations and anions are both octahedrally coordinated because the valency ratio is same, right? So that is done. So correct combination, fifth question, the correct combination of lattice and motif for the zinc sulfide structure. So the zinc sulfide structure, so basically what they have is, let me just draw the zinc sulfide structure. So this is your zinc sulfide structure. So now so x 10, so that is the thing. So x is at 0 0 0. So at the faces, right? So this is ACC structure. So they should also be at the face. Okay. So this is the thing. And this is sulfur. So zinc, the cations will be tetrahedrally coordinated because Zn, so Mx, depending on the RR ratio. So zinc sulfide. So this is uh, so zinc sulfide. Zinc sulfide, right? Zn. So Zn is to S valency ratio is 1:1, right? So solution is also 1 for that reason. So also, but the RR ratio signifies coordination number is tetrahedrally coordinated, right? Tetrahedrally coordinated means 4 neighboring atoms, and depending on the valency of your zinc and sulfur, which is 1:1, zinc should also be tetrahedrally coordinated and your sulfur should also be tetrahedrally coordinated, right? So the zinc, which sits at the tetrahedral void. So okay, so let us draw the zinc at the, which is at the tetrahedral void. So this is basically because of these and this. So basically this is the tetrahedral and the zinc sits at the tetrahedral void, right? So this is zinc. So this is zinc and this is red is okay. Right. So but if you put all, so last time we read about that there are this tetrahedral voids for an FCC structure. They are along the four body diagonals. So one will sit at 1 by 4 and the other will sit at 3 by 4 of the same diagonal. By that prescription, you think that along, if this is the body diagonal, this is the body diagonal, uh, right? So it is the body diagonal. So one can sit here, so 1 by 4 and then 3 by 4. But you have this bonding rule, right? Now you have the coordination number in mind. So if you just think about it, go home and think about it, that if you put all the tetrahedral voids, if you put atoms or ions at all the tetrahedral voids, you'll violate the four tetrahedrally coordinated rule. Means that it for some zinc cation, it will have more than 4 your neighboring anions, right? So here you cannot fully populate the tetrahedral sites, but only 4 of it. So there are 4 body diagonals. So in principle, you should have 4 into 2, 8 tetrahedral voids, but you cannot populate all the tetrahedral voids. You have to have this 50% or half filled population, right? So think about it, go home and think about it, just that you draw the all the 8 tetrahedral voids occupied by the zinc cations, and you'll see that the coordination number of 4 will be violated in some case, right? So that's why there's a 50% population. And the best scenario that best explains the FCC, this structure of the zinc sulfide, is that this is the FCC lattice. This is of course an FCC lattice. FCC lattice with, your sulfur will be at 0, 0, 0, right? And your zinc will be at 1 by 4, 1 by 4, and 1 by 2, right? So this is the correct option, that FCC lattice with multiplier, your FCC lattice with multiplier 0, 0, 0, and 1 by 4, 1 by 4, and 1 by 4. Let us, if you consider this as 0, 0, 0, and your coordinate system is like this, coordinate system is like this, then this basically is your 1 by 4, 1 by 4, 1 by 4, 1 by 4, right? So this is a, now the next question, which is, which of the following either are true for ABTO for spinal structure? So 4 options are given. You can always look into the video and get the answer, that oxygen makes an FCC lattice with 8 formula units in one cell, right? So this is the option. And the ions occupy the A ions, I mean AB2O3. This is AB2O4, sorry, AB2O4. A ions occupy the tetrahedral voids, while B ions occupy the octahedral voids. So these 2 options are correct for, as you have already learned in the video, which I don't have to add much, just that you go to the video and look at it. This is absolutely the case. Okay. Now this is a typical question. So which of the following positions is or are occupied by the oxygen atoms in an antifluoride structure, potassium oxide? Consider that the lattice is made by the anions, while interstices are filled by the cations, right? So in the video you must have seen, let me again. So you have 8 cubes for that calcium fluoride structure. So this is your basically your, this is your base structure. Let me draw this way. Okay, for simplicity, right? So this is here. Okay. this is this, and this is this. So you have to now divide the cube into 8 cubes. How will you do that? This is very simple. So you divide this into half, divide this into half, divide this into half. You also divide this into half, divide this into half, and in the middle you also have a division at the middle. This will also divide, right? So now the cubes are like this. So this is also divided, right? So planes will be like this, right? So so this is one cube, and this is another cube. So this is done. So 8 cubes into, so for CF2, for CF2 calcium fluoride, the fluorine anions will sit in those places like this, this, this. So there are two sets of HCG, the interpenetrating lattices. Okay, so also at the faces, right? So also at the faces here, 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 and also the middle of the edges, right? So basically, also the middle of the edges. Okay. Yes, so here the background. So these are the fluorine atom atoms. Okay, and so for CF2 you have to decide that CF2 calcium, so RR ratio denotes R CA2 plus R minus, this is 0.7 to 0.8, right? So this belongs to the category that 0.8 that belongs to the cubic, right? Okay, so cubic category in that case would be your cation coordination number. Coordination number is 8, right? That case, so nearest word is 8, but you have to take into account the valency, right? So CA is to F, this is 2 is to 100. Okay. If I have not done any mistake, so this is, yeah, so Ca2 plus and F is minus 1, right? And stoichiometry is stoichiometry is 1:2, right? So natural. So if the coordination number of for one uh, let's say for calcium atoms it is 8, right? But for the fluorine it has to be 4 because depending on the valency ratio. So these are the fluorine and calcium will not be able to sit at the body center of each of these 8 cubes, because by that protocol you'll have that for nearest neighbor of the fluorine anions will be in that case also 8, because for this fluorine atoms it will be this in that case, and also on top of it there will be 8. So to avoid that, you fill the calcium cations as in this cube, in this cube, in this cube, and in this cube, right? So the calcium calcium cations, sorry, calcium cations will go into those body centers, because in that case you will have 50% occupancy, because if you put in these cubes also, uh, in that case the fluid will have a nearest neighbor uh, uh, for that case. So to avoid that, you're putting only 50% occupancy in the calcium cations. So this is for the fluoride structure. So if I draw this schematic or whatever it is called, this 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 right. So this is only the z direction position of cations. So this is this. Okay. Also at the center. These are half, this is 1, this is 1, this is half, this is half, and this is calcium, and today will this okay 1 by 4 3 by 4 3 by 1 3 by 4 right. So these are the so what happens is that this fluorine ions will form two interpenetrating FCC lattices, and so does the calcium cations, right? So there are three interpenetrating FCC lattices, and if you just shift it by this, just by 1 by 4, you'll have that another that the fluorine ions sits at the corners and at the edge centers, right? So by that prescription, fluorine ions will be at the corners of the simple cubic lattices, just like this, and the your if you just shift this by 1 by 4, and the calcium will sit at the 1 by 4 positions in that case. So but for antifluoride, this calcium this is for antifluoride, this is CF2, right? CAAX2 for antifluoride. This is K2X, meaning that the calcium will be replaced by the oxygen, right? This is just the opposite. So earlier the calcium used to sit at this, let's say this at the edges, and also at the vertices and corners, and also at the edge centers. Similarly, for the antifluoride, what you'll see is that the oxygen will sit at the edge centers of the unit cell, and also at the face centers of the unit cell, and also at the corners of the unit cell, right? So just like fluoride, it will just be the opposite. Earlier it was the calcium that was sitting at the face centers and also at the corners of the unit cells. Now the oxygen will sit at the corners and at the faces of the unit cell. Yes. Okay. So corners of the unit cell will be 1, and face centers of the unit cell, just the opposite to the CF2 structure. Face centers of the unit cell, and also at the corners of the unit cell. Okay. And it is already mentioned that consider lattice is made by the anions, right? So you have to put the anions, the FCC structure will be made by the anion. So oxygen in that case, A2X or K2O, here you have specifically given. So the faces of the unit cell will be occupied by the oxygen ions, and also the corners of the unit cell. Okay. So consider the figure. This is the next question. Consider the figure given below with X open circle and Y dark circle size as level. So the site level as Y in the unit cell represents. You can always answer this. So these are octahedral voids, right? So this is easy. We have already encountered this. These are octahedral voids. Okay. the coordination number of site labeled as X in the figure as in question 8 is, so this is basically your NaCl type of structure. So both are octahedrally coordinated, so the coordination number will be 6. Okay, so this is very simple. Which one of the following type of compounds adopt the crystal structure shown in figure in question 8? This is your Ni, right? So it belongs to the NaCl type of class. So basically you have this NiO as the correct option. Okay. So in cesium chloride structure, the bond strength of cations. So cesium chloride RR suggests that it is octahedrally coordinated, right? Okay, octahedrally coordinated. Okay, so cesium valency, as for valency, cesium is to chlorine is 1:1. Right? So the bond strength which is given, which is I can obtain, which is sorry, bond strength rule. So valency of ion divided by coordination number, right? So valency in that case is 1 and is coordinated. So okay, sorry, this is not octahedrally bond strength rule. Sorry, this is cubic, actually cubic. So cubic, right? So in that case, let me just check. So cubic. So cesium chloride. Let me just check. I was making a mistake. Cesium chloride. Yeah. So this is cubic, right? Right. That is absolutely the case. So it should be cubically coordinated, right? So valency is 1. So this is 1 by 8. So cubically means 8 nearest atoms, right? So basically, we already done the drawing. So now coordination number is yeah. So for the CF2, this is basically you're not in the octahedrally coordinated voids. So nearest number coordination number is 8, right? So in that case, sorry. So in this case, so sorry, maybe I made a mistake. So this is cubic, right? Cubic. Sorry. So this is cubic. Sorry, this is cubic. So number I was making a mistake that I was saying octahedrally. So 8 nearest neighbor atoms, that means cubic. Octahedrally means 6 nearest neighbor atoms, right? So in case of cesium chloride, so there is not the restriction of the valency of 2:1. So it basically both the cations and the anions will be cubically coordinated, right? So in that case, so maybe I made a mistake that I said that for CF2 it is octahedrally coordinated. So coordination number is 8. You can naturally think that it is cubic. So basically for cesium chloride, you can have the atoms at both at 8 of this cubes. So it will be cube atom here, and atom here. So in total 8, right? So cesium chloride, this bond strength of cations is there are 8 coordination number. A number of coordination number is 8. So the bond strength of cation is 1 by 8. So 1 by 8 is the correct answer. So which type of cation coordination is present in cesium chloride structure, which is your cubic, right? So cubic coordination, which we already saw, this is cubic coordination. Okay. Now last 3 are very informative sort of. So as we already know, which of the following structure is most similar to perovskite structure? So perovskite is your perovskite would be let me just draw for just showing purpose. So this is your yeah. So this is your uh, So this is your A. So this is your oxygen. So this is your oxygen. Uh, uh, you know, okay. So large E, A is your okay. So 630. Right. Okay. Large garden B, oxygen. So that is the case. So now let me just draw the phases. Okay. So now let's say that the center is your E. Okay, and this is your A, and this is your plus oxygen at the faces, right? So oxygen, this is your oxygen. So this is the pyramid structure. Now ReO3, let's say ReO3 structure is close with similar to the perovskite structure, which you have already noticed, is that this is your ReO3 structure. This is ReO3 and this is perovskite. Perovskite structure. Okay. So basically, M, this will be at the right, and your X, which is oxygen, will be at 0, 0, 0, which is the faces. This, and also the uh, uh, so also this is also. So basically, because of just ReO3 structure, which is perovskite structure, is you know, just put the A's out of the equation, and you got the ReO3 structure. Just there are the edges of it, right? So basically, the ReO3 structure is closest to the perovskite structure. So the next question is, pick out the correct statements in the following. The first option is, in zinc sulfide structure, only 50% tetrahedral bonds are occupied by Zn atoms, right? So this is correct. As I already told you that because of if you put at the tetrahedral sites, if you put the atoms zinc atoms all the tetrahedral sites, you will find that the coordination number of 4 will be violated in some cases. The second option is not correct because above the Curie temperature it is cubic for perovskite material. In Ab2O4 spinal structure, tetrahedral void occupancy is 1/4, while that of octahedral is half. So this is correct. So oxygen atoms have octahedral coordination in ReO3 structure, which is not case. So oxygen atoms. So this is the oxygen atoms. So this is the oxygen atoms. So they are linearly coordinated. So nearest neighbor is your 8. 2. Sorry. For the octahedrally coordinate for Re type of atom, that is your octahedrally coordinated, right? So this is your oxygen, right? So this is ReO3 structure. So they are linearly coordinated. So this is not the correct option. And the active position in CSCl2 structure is 0, 0, 0, half, half, 0, half, 0, half, 0, half, half. This is not the case because they are at the let's say for half of half there is also atoms. So this is absolutely not the case, right? So half of half is not the case. So they sit at the body centers of each of these 8 cubes. So the atomic positions, if had that been 0 half half, it will be at the base or at the faces of the cube. So this is not the case. So that's why the atomic positions are not correct, right? So which of the following is a parent compound in the formation of YPA2CO3 O7 minus X? This is YBCO. So the correct option is here Y3CO3O9. This is very informative sort of a question. So 15 questions are done. So Okay, so 8, 9, and 10. Okay, okay, that's very doable. 8, 9, and 10 is what? Okay, acha. So consider the figure given below with X open circle and Y dark circles as label. So see that this is basically the FCC structure with with all the octahedral voids being occupied, right? With these dark circles, right? The solid dark circles. So this is basically these octahedral points, right? So if you consider this atom, so this uh, this this atom will be an octahedral coordinate, right? So this atom will be octahedral coordinated. So this atom, so this atom at the center will be octahedrally coordinated, and same goes with all the dark colored atoms or sits at the edges and at the body centers, right? So this is basically octahedral by the site labeled as Y. So the coordination of site labeled as X in the figure in question. So coordination of X is this solid, vacant circles, right? Open circles. So basically they'll have 6, right? So this in this direction, in this direction, in this direction, and this and above it. So there are 6 nearest neighbor atoms in total, and you have to take into account the nearest neighbor cubes also. So this it will fall on a different cube, and this and top will fall on a different cube. So the site marked as X will have 6 nearest neighbor atoms, so they're octahedrally coordinated. And so maybe 8, 9, and 10. Okay. And 10, and as I showed you that this is a NaCl type of structure, so belonging to the same category is NiO, right? So this is NaCl structure, so this is NaCl structure, this is NaCl structure, right? So the NiO was under that same category, and so that's why they have the same structure. So is this clear? I mean 8, 9, and 10 I have repeated. So if you have any further questions or queries, please do. Yeah. So do you find it easy with these sessions? Like, yeah. Okay. Okay. So you are getting help, right? I mean, understanding the concept, and please also you can also ask ask me in the next classes also, like questions from the previous classes, right? So today was a session of the big assignment. So basically, if you find any problem, please do ask. Okay. So anybody has any question? Okay. So if you people do not have any question, can I call it a day? Can I wrap up? Okay, thank you. So see you in the next class. This with regarding the 6th assignment. So please do study from the videos and from these problem solving sessions, which will be uploaded. All right. So thank you, thank you.